Okay, so first we're going to show that for every natural number n, 10 to the power of n is congruent to 1 to the power of n, mod 9, which will equal 1 mod 9 because 1 raised to any power will be itself. So we can note, we'll first start off with part A, 10 is congruent to 1 modulo 9. Therefore, 10 to the n is just equal to 1 to the n mod 9 equals 1 mod 9. Now, this fact is obviously very easy to prove, but it's going to be very important and it's going to help out for proving the part B of this question. Okay, so for the next part, we have to prove both directions here. We have to prove that if A is congruent to 0 mod 9, then the sum of all its individual digits is also congruent to 0 mod 9. And then we have to prove the other direction, that if the sum of all digits is congruent to 0 mod 9, then A must also be congruent to 0 mod 9. We are first going to start by assume A, which can be written as xn, xn minus 1, all the way up to x1, x0, where this is not multiplication, these are just the individual digits. We will assume that this is congruent to 0 mod 9. We can note that A can be written as 10 to the 0 times x0 plus 10 to the 1 times x1, all the way up to 10 to the nth power times xn. And in summation notation, we can write this as from I equals 0 to n, xi 10i. Using part A, we know this value, xi 10i, mod 9, is congruent to n from I equals 0 to n, xi times 1 to the 9, or 1 to the I, excuse me, which is equal just to from I equals 0 to n, xi mod 9. Now, we know that the sum of xi mod 9 is congruent to A equals 0 mod 9 if the sum equals 0 mod 9, meaning 9 divides the sum of the individual digits. So we have proven one direction here. Now we'll have to assume that the sum of the digits is equal to 0 mod 9 and use that to show that A must also be congruent to 0 mod 9. Now, to show the other direction, we assume that the sum of the xi's, the individual digits, is equal to 0 mod 9. We may recall that, check, recall that A is equal to, from I equals 0 to n, xi times 10 to the power of I, which in modulo 9 equals xi times 1 to the I. Now we have assumed xi to equal 0 mod 9. So a equals 0 mod 9 times 1 to the I mod 9. And this will equal 0 mod 9. So we have proven both sides of the if and only if statement. Therefore, we are done.